Hello, Yawning Angel back again. It's another AMOS video, and this video is all about samples and how to play them back within your AMOS programs. So hot on the heels of my last video, a link up above, where we looked at the play command for creating musical tunes within your AMOS programs. This time we're going to look specifically at samples that you have on your Amiga and how to use them within your AMOS programs. But before we dive in, I have some thank yous to make. So very quickly, some thank yous need to go out to the following people. Hoffman, yes, DJ Hoffman, who pointed me in the direction of a piece of software called Audacity that I could run on my Mac, and that would help me convert sound files. Also to a piece of software called SoundBox on the Amiga, which would do a second conversion. More on that later. Also, a long-time subscriber and friend of the channel, Frank Walker, who helped me fine-tune my Audacity settings when trying to export sound files. Thank you, Frank. And finally, a gentleman called Richard Korber. Thank you, Richard, for creating the software called SoundBox many years ago on the Amiga, which is still available today on Aminet. I'll post a link in the the description, down below. But SoundBox, great piece of software. We'll have a quick look at that later on as well. So thank you very much, all three of you. Without your help, this video would not be happening. So in this video, what we're going to do, we're going to take some sample files which we already have on the Amiga. We're going to load them into the sample maker in AMOS Pro, and we're going to create a sample bank file, which we will then load into a program that we write, and we'll extract the samples from that sample bank file and play them back and control them as we want to within the program. This is very, very similar to the way you would have a sprite bank for your graphics. AMOS Pro deals with this in the same way for samples as well. And yes, you can load in raw samples into your AMOS Pro programs. We will not be looking at that. We're purely looking at the sample bank. Also, you probably want to know how I got to this point. Right, so in order to create this program and to create the sample bank, I needed some samples. So what I did, I recorded some sounds, you'll hear them later, on my iPhone. And obviously by recording them on there, they were in the format M4A. I then needed to get them into a WAV format. Ultimately, you need to get these samples into an IFF format for the Amiga to read, but there's a process to go through. So with the sound samples on my phone, I transferred them to my Mac, I loaded them into Audacity, and within here I trimmed them. I had to make some frequency changes. We won't go into that in this video. If there's call for it, I can cover that again in another video. But what I needed to do was adjust the frequency and then convert them to a WAV format, which I did. So I saved them out from Audacity. I then transferred those files onto the Amiga, loaded them into SoundBox as WAV files, and within SoundBox you can convert them to IFF, save them out as IFF files, which I did. Once they were saved out as IFF files, they were then free to be able to be loaded into the sample maker within AMOS Pro. A bit of a process, but it's well worth getting there when you hear the results. So without further ado, let's get a cup of tea and dive on into some coding. Okay, here we are in AMOS Pro. Quick mouthful of tea. Oh, that's good. Right, so within AMOS Pro, we're going to go to the, turn that sound on. We're going to go to the user menu and select Sample Maker. Now, in the Sample Maker, we've got various icons that enable us to load samples in and create a sample bank and save that sample bank back out again. So quick whistle stop tour. We've got a quit button, which unsurprisingly takes us out of here. This is our bank information here, and there's no information there at the moment because we haven't created a bank. Down here, this icon will enable us to load a sample in. Remember, you have to bring them in IFF format. This icon here, save a sample out. This one here, change its name. This one here, remove it. Then on this side, we've got the bank save and load controls. So this icon here with the disk with the arrow pointing out from the chip is to save our bank. This icon here is to load the bank in. This one's to delete a bank. This one to insert a sample in between two other samples. That one to remove a sample. Over here, the gramophone record icon is to play a sample back, and then we've got some arrows over here which enable us to change the frequency of the sample while it's in here. I found these to be a little bit ineffective, so I had the sample brought in at the right frequency to start with. Your mileage may vary, go with what works for you. Right, so I'm going to load a sample in, so I'm going to dive into my IFF files. And I have a sample, so let's bring this one in, and that should load beautifully. Look at that. So there's the waveform there. So if I turn my sound up and press the gramophone record icon, you should hear it. And that's it. That's quite straightforward. Now, it's there, it's not in my bank, but what I do now is I select this right arrow here. Oh, no, I don't. I select the I select the slot that says empty. Then I select the right arrow, and that's loaded it in, and it's brought the name in as well, which is absolutely fantastic. So really pleased with that. So already I've got a bank starting to be formed here. So let's grab another sample, and let's grab Kaching 2. There's Kaching 2, and if I play that back, now empty is highlighted, so if I press the right arrow here, that loads that in. Let's grab another one. Let's do Kaching 3, and let's try that. So that's there, and so if I push that across, and I've got 3 samples in my bank already, which is good. Let's grab some more. What have I got? Let's try this one, P scale 1 IFF. These are guitar samples, and I want to say this is me playing guitar because I have a guitar which I use from time to time. So this should be a pentatonic scale, blues pentatonic scale, for those who are interested. So let's load this in, a slightly larger file, but let's give that a play. And if I push that across, that is now loaded into my sample bank. Please note down here, this is the frequency of the sample. So I went with 44,100, which I think, please correct me if I'm wrong, is CD quality frequency. Once again, audio, not my strongest point, but you know, let's just kind of go with that. But this gave me the cleanest sound, so I was quite pleased with that. Right, we'll grab a couple more. So what have I got? I've done some voices as well. So if I bring this AMOS Pro voice in, let's see what this sounds like.
AMOS Professional.
Sounds a little bit fast, and there's a reason for that. I brought it in as a faster sample so I can then scale it or slow it down within the AMOS program. Anyway, let's just dump that one into our bank as well. And we can grab a couple more. I think I've got Boing. This is one of my favorites. I quite like this.
Boing.
So that can go across. And I think there's one more. This one here. This should say welcome to AMOS. Let's give that a try.
Welcome to AMOS.
Yeah, nice. Yawning Angel the Chipmunk. There we go. So now we've got some samples in our bank. This is fine. So now what we want to do is actually save this out. So we're going to go to the icon here with the chip pointing to the disk, click on that, and it wants us to give a sample bank name. I've already got one in here. This is one I created earlier, but what I can do is sam bnk1_.abk, and we can save that out. Just click OK. So that, see here, it's actually saving the samples into the bank. And now it's given us the bank name has appeared in the top right hand corner. We are now good. Sample bank has been created. We can quit out of here, and now we can use it in a program which we're going to write. Huzzah! Okay, so with our sample bank created, we're now going to write a program around that. Now I'm going to use the sample bank that I created previously, just because that's the way I roll. So the first thing we're going to do is, after creating a sample bank, load it in. Exactly the same way as you would do. Oh, I'm going to turn the sound down on that because that's going to get annoying. a SMAPL bank. We don't want a SMAPL bank, Yawning Angel. We want a sample bank. Sample bank, load it in. Right. So we're not going to bother with too much screen real estate here because this is all about the audio. So anyway, so the first thing you need to do then is do a load, and you need to go to the path on your device, storage device of choice as to where that sample bank is. So for me, I know it's on my DH1 partition. It's in the samples folder. It's in a folder called IFF files, and it's called quick and dirty underscore SAMP BNK1.abk. So that is my sample bank. Just very quickly, I wanted to mention memory when you're using samples. If you're using a lot of large samples, they will consume memory. Please be aware of that. Maybe not too much of an issue on today's modern Amigas where we all have, memory expansions. And if you're running under emulation as well, you can control that. But please be aware, big samples take a lot of memory. And if you run out of memory, AMOS will alert you quite quickly. Okay. Also in the AMOS manual, more information on the SAM play command is in section 080201. More information on the sample bank 080203, and all the other SAM or sample commands are listed in there. We'll cover some of those in a future video. Right, let's get back on with the coding. Next, we're going to just set up a basic display. Display. Having trouble typing this. You need more tea, Yawning Angel. That's the problem. So just a rudimentary display. We'll turn off our cursor. We'll issue a statement, our command here. Press a key. Oh no, let's do this properly. Press a key, and then we're going to issue a wait key command. So what we're doing, we're loading the sample bank in. We're then going to issue an instruction to the screen to ask the user to press a key, and we're going to wait until that key has been pressed. Now let's get to the meat of the program, everybody. So play sample one. How are we going to do that? So what we need to be aware of is the SAM play command. This is the command we're going to use to play back a sample. It stands for sample play, and why wouldn't it? So there are some different formats of SAM play, and this is the one we're going to use. So what I'm saying here is, in this example is made up of, and then just do a quick apostrophe, and it's made up of voice, the voice parameter, which is effectively the channel, the sound channel that you're going to go to. So this is exactly the same as what it was for the play command. So if you watch my previous video, you'll see all the different channels, all the different voices, the codes for the voices laid out there. Also, what we want to tell it is the sample number from the bank, which we're going to play from bank, and then the frequency, i.e. the speed of that sample, how we're going to play it back. Okay. Then we're just going to issue a quick locate command 0,1, and then we're going to center playing sample one. Okay. Now, are you ready? This is it. Now we're going to issue the instruction. So here it is, SAM play, and we're going to go for 15 because we want it to go across all four voices, so all four channels. Okay. We're going to play back sample one from the sample bank because we've loaded the sample bank in here. We're going to take the first sample and we're going to play that back at a frequency of 32,000 basically. And then I'm just going to issue a wait command 100, and this will become clearer why we do that in a while. But effectively this is it. This is our SAM play command. So play back across all channels, sample one at a frequency of 32,000. Yawning Angel, how did you arrive at 32,000? Well, my friends, trial and error. Trial and error. You can play with that number to your heart's content. 32,000, I happy to be corrected, but as far as I'm aware, that is as high as AMOS Pro will go with its frequencies. Right, so let's run that and see what happens. So if I press F1, so there we go. On the screen, it wants us to press a key, and I'm just going to turn the sound up here, because when I press a key, and there you go. That is it. And the program has ended because that's as far as I have got with it. So, and that sample's come in pretty cleanly. I'm actually quite pleased with that. So let's do another one. So rem prep display for the next sample. This really is quick and dirty code. So 0,3, then we're going to center, press a key again, dot, dot, dot. Then we're going to do another wait key. Now we're going to rem play sample 2. Locate 0,4, and we'll center playing sample 2, dot, dot, dot. Okay, and now we'll do again sam play. So once again 15, because we're going to all the sound channels. Can you guess what the next number will be? We're playing the second sample from the bank, so we're going to put in 2, because that's what we want to play. And the frequency for this we're doing at 28,000, sorry. And then we'll just issue a quick wait 50 on there. We'll do that properly, Yawning Angel, without cutting corners. There we go. And once we've done that, that's it. So what we're going to do then, sam play across all channels, sample number 2, and it's at 28,000. Once again, trial and error is how I got to that. Please note, later on, we're going to adjust this program so we can play around with the frequency and get a greater understanding of how that sounds. But for now, this is just getting the samples up there. So let's turn the sound up and go through this again. So press the key for the first sample. Now we're going to do the second sample. And there you go. That is how you do it. Right, so I've got more samples to load, so I'm just going to write the code for those, and then we'll come back and we'll play them through, because you don't want to see me just type the same code over and over again. Please be aware, all the screen text and that I've just thrown on here just to show you the steps that we're going through, but really all you're interested in is that sam play command. So anyway, I'm going to write some more code and I'll see you back in a bit. Okay, so I've added in a lot more code here to play back more samples. Sample 3, sample 4, 5, 6, 7, and then we play back 2 samples together at the end across different sound channels. Something I'd like to add into this, I've added my usual disclaimer text in here. It's the usual thing that you've seen in all my other programs, but I just want to draw your attention to this bit. Any samples that I'm including with this are for personal use only and may not be used for commercial means. Just thought I'd stick that in there. You folks out there would probably want to use your own samples anyway, but I just thought I'd mention that. Right, so let's give this program a bit of a run then, and we can see what it does. So just turn my sound up, and here we go. Now we'll play the next sample. Now sample 3. Now sample 4. Now sample 5.
AMOS Professional.
Number 6. Wait for it. Wait for it.
Boing.
Number 7.
Welcome to AMOS.
It's never going to replace the voice at the start of AMOS, is it? Although if somebody wants to do it, crack on. And now this one, this is where we're going to play 1 sample to the 2 left channels and 1 sample to the 2 right channels. So,
Welcome to AMOS.
I love that. That gives me a real buzz. And that is as far as we've got. Fairly straightforward stuff. It is just a case of using that sam play command each time just to, tell it which voices you want to be using, which channels, what sample number, etc. and your frequency, and that is it. So for the bit where we played back 2 together, we come down to the end here, it was just a case of, here we go, sound play, so 9 will give me the 2 left channels, sample number 5 at 28,000 hertz, and then sound play 6, which will go to the right channels, sample 7, 28,000 hertz, and we fire it, and that is it. And now we're ready to have some fun. So now we're going to write some code that will enable us to choose one of 3 samples, and we can adjust the frequency on that sample that we choose and play it back to hear how the frequency affects the playback speed. So I'm going to write a bit more code just to get us up and running, and then we'll dive in and have a closer look at it. All good. Okay, I have added some code in here, so let's play around. So the first thing we're going to do, we're going to clear the screen, turn off the cursor. Then we're going to initialize a couple of variables. So the first variable is SA, we're setting that to 0. So SA we're going to use as the sample number. Remember, you're going to be able to choose one of 3 samples to play around with, and this will be the value that holds that sample number. We've then got another variable called FR for frequency, and we're setting that as 28,000 to start with. Then we're just going to throw some instructions on the screen as to what each key does. So effectively, you're going to be able to load a sample in, you're going to be able to decrease and increase the frequency, just play it back on its own, Q will quit the program, and N will enable you to select a new sample, and the sample range you have is sample 5, 6 or 7. These are the samples from the sample bank that have my voice rather than the guitar sound. You can change this to your heart's content and do whatever, I'm just doing this as an example. So then we issue an instruction here which will ask the user to key in a number to select a sample. So we're going to do this very, very, very quick and dirty, and we're going to issue a while statement here. So while SA equals 0, so while the sample number is 0, we want this input command to run sample question mark, and then we do a apostrophe for semicolon, sorry, not apostrophe, and then we do a while end command. Let me just F3 that. So what this is saying, while the sample number is 0, which we've set it to 0 up here, basically just want the user to input a value. So as soon as they input something and press enter, then we'll come out of this while statement. What we want to do is only perform the main loop of code if the sample number is valid. And to do this, we're going to check, let me just come out there a minute. What we're going to do is do a check on if SA is greater or equal to 5 and SA is less than equal to 7. And let's end if on there. So what we're saying is if they've entered a value between and including 5 and 7, then we can carry on and do the main chunk of code. So the next thing to do will be to tidy up the screen a bit, which is just going to get rid of a load of text that I don't want. So it'll be a quick case of locate 0, 9, and I just want to print a load of stuff over that, just to get rid of some stuff that I put up on the screen. This is not mandatory, it's entirely up to you, but it will make a difference to how the screen looks. Just some spaces there. Right, okay. Now we're going to do a do loop. And what we're going to do in here is, once again, turn the cursor off, and then we're going to do a quick locate 0, 11, and we're just going to issue a quick statement which will show what sample we are playing. Print playing sample :space. Then I want to do that, and then I want to do SA. So whatever value someone has given us, that'll be the sample we're playing back. Okay, So locate 0, 13, print frequency, colon space, semicolon, FR. So this here is showing the user what they've selected and what is actually happening. It's giving information back to the user. We're then going to assign $, will equal in key string, because we want to now scan the keyboard for input, which is why we're in this loop. So I'm just going to press F3 just to tidy that code up. So the first thing to do then, so if $, equals P, so if, good practice to get your end-ifs in straight away. We are going to issue the command sam play across all channels, 15, the sample number we've chosen and the frequency that has been selected. Okay, so that's what get my teeth in. This is where those variables are going to come into play. Sample number and the frequency number. So that is just if someone presses P, it will just play whatever sample has been selected. So the next one then, if $, equals Z, and the frequency is greater or equal to 1000. Okay, so if they press Z and the frequency is greater than 1000, we're then going to FR equals FR minus. So this is the increment that we're bringing the frequency down by. So if they press Z to decrease the frequency, we're going to bring it down in steps of 1000. You can change this code to be tens or hundreds, whatever you want, but thousands will give you a greater visual and audio representation of what the frequency is actually doing at this point. And for this example, I think that's quite important. We're then, as soon as we've changed the frequency, we're going to issue the sam play command again. And so that'll be across all channels, sample number, comma frequency number, and then our end if goes in there. And that is that. Now we're going to do the same for increasing. So if $, equals X, and the frequency is less than or equal to 31,000, then we're going to FR equal FR plus 1,000. So we'll change the frequency in a step of 1,000, we'll increase it, and then we'll just issue the sam play command again, 15, SA, FR, end if, F3 to tidy that up. Save that. That's what we've got. So we've got the P key is being checked here, the Z key and the X key. We are playing back the sample on its own, or we're reducing the frequency and playing it, or we're increasing the frequency and playing it. So let me just run that. The whole program will go through playing those samples, but I'll just quickly fast forward and we'll get to the screen we need to be on so you can see this working. Awesome. Right, so I've run the program up to this point now. So we've got our instructions set up here. Select sample 5 to 7 to play with, anything else to end. So that's, if we do any other number, it should end the program. I didn't show you that, but we'll show you that in a bit. Right, so let's select a sample. So let's select sample number 5. So it is now loaded in sample 5 and it's shown us what the frequency is. So if I press P.
AMOS Professional.
See, listen to that, you hear it?
AMOS Professional.
Let me just adjust my chair, that's better. Now, if I press Z, it'll decrease the frequency by 1,000 and play it back.
AMOS Professional.
Not hearing much of a difference. Let me do it again.
AMOS Professional.
And I'll keep going.
AMOS
Professional. AMOS Professional. AMOS Professional. AMOS Professional.
So you can see the impact of the frequency adjustments there. So if I press X, we'll go back up.
AMOS.
There we go.
AMOS Professional.
Press and hold X.
AMOS Professional. AMOS Professional.
Up to 32,000.
AMOS Professional. AMOS professional. AMOS professional. AMOS professional. AMOS professional.
How much fun is this? You could just do this all day, couldn't you?
AMOS professional.
Right, I'm now going to write the next bit of code which will enable us to select another sample and do exactly the same thing. But this is just a demonstration of how you can adjust the frequency to get the different sounds from your samples. Right, let's get the next bit of code written. Right then, so the last bit of code we need to write then is handling if the user wants to select another sample. So we're going to do is if a dollar equals n, so they've pressed n for a new sample. We need to locate 0, 15. We are going to input sample question mark SA. Very similar to the code we had above. Then we'll just do some very, very, very quick and dirty validation on here. So if the number that they enter is not equal to 5 and SA not equal to 6 and SA not equal to 7, we'll just end the program and end that end if there. That's all we need to do there, which is quite straightforward. So if n is pressed, we just ask for a new sample number. Whatever they key in is stored in the variable SA. We check to make sure SA is either 5, 6 or 7. And you're probably thinking, if you don't know this, I'm saying 5 or 6 or 7, but the code is saying and 5 and 6 and 7. It's because we're doing not equal, because you can't have SA equaling 5 and 6, but you can have SA not equaling 5 and not equaling 6 and not equaling 7. Okay? Simple logic, it all works. Right, outside of that, we want to handle pressing Q to quit the program. So if a dollar equals Q, we'll just do a very straightforward end. We'll end that if, that's fine, we'll tidy that up. We will then also come to the end of the program here and actually type in an end. Just quickly tidy that up, we'll save that. And now we'll run the program and see it running in its entirety. So let's do that now. Right, here we are. Program is set and ready to go. So let's choose a sample. Let's choose sample number 6. Let me turn my sound up. So sample 6 is loaded in. It's at a frequency 28,000. Let's press P.
Boing, boing, boing.
Hours of fun with this. Right, let's bring the frequency down. So I'm just going to press and hold Z.
Boing.
And this is probably why you don't want the lower end frequency to go down too low, because it plays it back so slowly. How much fun is that? So I'm going to press X now to bring that back up. I'm going to press and hold X.
Boing, 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 boing.
Coming back down
Boing.
again, obviously.
Boing, 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 boing.
Have so much fun with this. Right, I'm going to press N. Ask me for a new sample. I'm going to do sample 7. Sample 7 is now loaded in. If I press play,
Welcome to AMOS.
it's still using the same frequency as we were using last time. So that's fine. I can press X to increase that.
Welcome to AMOS. Welcome to AMOS. Welcome to AMOS. Welcome to AMOS. Welcome to AMOS.
This is so much fun, isn't it? I can press N again, which will take me, I can now choose sample 5. Let's play that, press P.
AMOS Professional.
Go up the scale.
AMOS Professional.
And again.
Professional. AMOS Professional.
Go down, press and hold Z.
AMOS.
AMOS Professional.
And really, that's all there is to it. You can just have so much fun with this. If I press Q, it's going to end the program. And we're all done. It really is that simple. You can play around with the code to your heart's content. I would suggest having a play around with, turn that down. I would suggest having a play around with your frequency settings, maybe having this in hundreds or 10 so you can fine tune it. That is up to you. You can play around with voices as well. You can have another input for what channel you want these to come out of, so you can set that. Effectively, anything in that SAM play command you can have as a variable. So we can have the voices as a variable as well. And that's it. That is the SAM play command in AMOS Pro. We've loaded samples in from the Amiga into a sample bank within AMOS, and we're playing them back and we're fiddling around with them. We've got some user control over them. I will take that as a success. Happy days, all good. And that is it for another video. Thank you ever so much for watching. I really hope you've managed to get something out of this and it has been of use to you. Don't forget the source code and the sample files for this program are available for free download on my website. There's a link here. I'll put the link in the description notes down below as well. But you can download the program and have a bit of a play yourself. If you like the video, give it a thumbs up, subscribe to my channel if you wish. I do a number of these AMOS videos and other retro computing videos as well. I can be found on various social channels. There's a list up here. I can also be found on Ko-fi. If you'd like to support my work, feel free to head over there. I'd like to thank everyone who has subscribed and all the wonderful comments I get from people about these videos. It's amazing. And also don't forget, I write AMOS tutorials for Amiga Addict magazine as well. So be sure to go and check them out too. Shameless plug, and I'm not being paid to say that. I just want to promote my work. Right, thanks ever so much once again. That's it. So until the next video, whatever you do, keep it retro.